Okay, today we're going to talk about isosceles triangles and do some proofs with isosceles triangles. I know you can't wait. The definition of an isosceles triangle is if a triangle has two congruent sides, then it's isosceles. So here's a picture of an isosceles triangle. This is called the vertex angle, and the side that is not congruent to another side is called the base. And the angles that are on each side of the base are called our base angles. So the base is the included side of our base angles. Remember that? Okay, so if this is our base, then that means that this side is congruent to that side. This is an isosceles triangle. Okay? So the converse of that definition is also true. Remember, definitions, converses are true. So if a triangle is isosceles, then it has two congruent sides. So if I told you that this was isosceles, so you knew it had two congruent sides. Okay, so based on sides, side lengths, what are some other classifications of triangles we know about? Well, isosceles, we're just defining this as two congruent sides. Well, there's also equilateral triangles, which means all of their sides are equilateral, and scaling, which means none of the sides are congruent. Okay? So of these, can any of these be isosceles? Well, if a triangle is equilateral and all the sides are congruent, then at least two sides are congruent. So equilateral triangles are also isosceles triangles. Okay, now let's talk about the base angle theorem. Again, back to our picture. These are the base angles because this is our base. The base angle states that if two sides of a triangle are congruent, then the base angles opposite them are congruent. So like I said, these two sides are congruent. Well, the angle opposite this side is this angle, and the angle opposite this side is this angle. So if the sides are congruent, then the angles opposite the sides that are congruent. So that means our base angles are congruent. Converse states that if two angles of a triangle are congruent, then the sides opposite them are also congruent. So if I gave you a triangle and I didn't tell you that these sides were congruent, but I told you that these angles were congruent, well then you could use the converse of the base angle theorem to say that the sides opposite the angles are congruent. So that's our base angle and the converse of our base angle theorem. Okay, whoops. So if you're given an isosceles triangle, somebody tells you you have an isosceles triangle, then your next step could be to assume that you have two congruent sides. You know you have two congruent sides if it's an isosceles triangle. And if you're given two sides of a triangle congruent, then you know using the base angle theorem that the base angles are congruent. If you are given that two angles of a triangle are congruent, then you know, because of the base angle theorem, the converse of the base angle theorem, that you have two congruent sides. Okay? So these are all things you can use in your proof. But what you need to actually prove, what you need your final statement to be before you say it's an isosceles triangle, is you have to show that there are indeed two congruent sides. Okay, so let's do a proof. If we are given that LIO, triangle LIO, is isosceles with base LO, and that's important to know which one's the base, because we don't know which sides are congruent unless we know which side is not congruent. So since they told us that LO is the base, then we know that the other two sides are going to be congruent. So since that's the base, LO is the base, then we know that these two sides are congruent. We're also told that N is the midpoint of LO. And you know what midpoint means, right? It divides a segment into two congruent segments. So then you know that those two are congruent. Now what we want to do is prove that IN bisects this angle, LIO. So if we can prove, you know that the angle being bisected will create two congruent angles. So one way we can see if those angles are congruent or prove that they're congruent is to prove that these triangles are congruent to each other. Now in our given, we were given these two sides, and do you see something else we can use? Here are good old INs congruent to itself by the reflexive property. So now we've got enough information to do our proof. So again, start out with your given, restate it. Don't change anything in your given. I've noticed that in some proofs. Some people change some things in the given. State it just like it is here, and your reason you can say that is that it's given. Okay? So now we can say that LI is congruent to IO because we were told it was isosceles, so we know if it's isosceles, then it has two congruent sides. And the two congruent sides are the two that are not the base. Okay? We also said that LN is congruent to NO because N is the midpoint. So that's the definition of midpoint. So you've got those segments congruent. And you need to state that IN is congruent to itself by the reflexive property. So now you have stated segment, 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 side, side, side. So now you can state that those triangles are congruent by the side, side, side postulate. And you can state that this angle, LIN, is congruent to OIN, to this angle, because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, but you're not done. You have to say what you're actually trying to prove. But since you've got two congruent angles here, you know that IN bisects them. So now you can say IN bisects angle LIO, and that's the definition of bisect. Okay, let's do another one. Here we're given this figure and the fact that triangle ABC, this whole triangle, is isosceles, and that the base is AC. So since it's isosceles, we know that we have two congruent sides. Since this is the base, then this must be the sides. These must be the sides that are congruent. We're also told that the measure of AD equals the measure of EC. Okay? So those are going to also be congruent, but it tells us that they're equal, so we're going to have to state that they're congruent. Okay? But we can go ahead and mark those. Now we want to prove that this triangle BDE, so this triangle here, we want to prove that that is an isosceles triangle. Well, to prove it's an isosceles triangle, we're going to have to show that it has two congruent sides. So if we can prove that BD is congruent to BE, then we'll show that it has two congruent sides, and we can say it's an isosceles triangle. Well, one way to get this side, we can say that this side's congruent to this side, is if we can say that these triangles are congruent, ABD and CBE. If we can say that those triangles are congruent, then we know that these sides are going to be congruent to each other because the corresponding parts of congruent triangles. And then, can you see that triangle in the middle? Then we can say that triangle is isosceles. Well, what can we work with? We're given a side and a side. We're trying to prove these two sides, but I don't know how to get there. But what if we had a side, an angle, and a side? Is there something that tells us that angle A is congruent to angle C? Well, we've got the base angle theorem. We're given ABC, this big triangle, is an isosceles triangle. So, using the base angle theorem, we can state that angle A is congruent to angle C because they are the angles opposite the sides that are congruent. Okay, so I think we can do this. Again, state your given, just like it's stated right here. That's your first statement always. Then you can state, you need to state that AB is congruent to BC. Those segments are congruent because it's an isosceles triangle. So if it's an isosceles triangle, then it has two congruent sides. Okay? And in addition, since it's isosceles and has two congruent sides, we can use the base angle theorem to say that angle A is congruent to angle C, the base angle theorem. Okay, remember I said that just because the measures are equal, we still have to state that the segments are congruent. We need the congruent statements in the proof. So you can just state that those are congruent because if the measures are equal, then the segments are congruent. Okay? So now we've got a segment, the side, an angle, and a side. So now we can state that those two triangles, ABD and triangle CBE, so this is ABD and triangle CBE, we can state that those are congruent by using the side angle side. Okay? All right, we're not done though. We've stated that the triangles are congruent. Now we want to state that these sides are congruent. So now we can state that this side is congruent to this side because corresponding parts of congruent triangles are congruent. So we had to prove the triangles were congruent first. Now we've got, see that middle triangle again, BDE? Now we've got two congruent sides of that triangle. So we can now state that triangle BDE is isosceles because if two sides of a triangle are congruent, then the triangle is an isosceles triangle. And that's the end of our proofs.